1.2, Quadratic Equations. A quadratic equation is of the form ax squared plus bx plus c is equal to 0, where the a term does not equal 0. We need an x squared term in order for it to be quadratic, so that's why the a cannot equal 0, and the equal 0 part makes it an equation. In order to solve quadratic equations, we need to be familiar with the zero product property. It states, let a and b be two algebraic expressions, then a times b is equal to 0 if and only if a equals 0 or b equals 0. What that means is if we're multiplying two things together, in our case it's going to be factors, the only way those two factors multiplied together are going to equal 0 is if one of them is equal to 0. Example 1. Solve by factoring. We have x squared minus 8x equals 0. To solve this, what we want to do is we have the equal 0 on the right-hand side, so perfect. Now we want to factor the left-hand side. To do that, remember you always want to look for a greatest common factor first. In this case, we have our two terms, x squared and minus 8x. And when we look at those, the greatest common factor is an x. So I want to factor out an x, which leaves me with x minus 8. Then I can use the zero product property and set each of those factors equal to 0. I get x equals 0 and x minus 8 equals 0. X equals 0 is already done, so that's one solution. Then I add 8 to both sides, and I get x equals 8 as my other solution. Example 2. Solve by factoring. 6x squared plus 11x equals negative 4. On this problem, we don't have 0 on the right-hand side, so I want to fix that. To do that, I'm going to add 4 to both sides. When I add 4 to both sides, that's going to give me 6x squared plus 11x plus 4 is equal to 0. Now I have it in the right form, and I want to go ahead and factor. Again, I look for a greatest common factor first. There isn't one, so I move to my methods of factoring trinomials. So the AC method with the grid that I taught you guys. So I'm going to give you a minute to go ahead and factor this on your own, and I'm going to silently factor on the side, and then you can check your factors with my factors. Alright, hopefully we were able to come up with the two factors. The two factors were 2x plus 1 and 3x plus 4. Now using the zero product property, I'm going to take each of those factors and set them equal to 0 and solve. So this gives me 2x is equal to a negative 1 when I subtract 1 from both sides. So x equals negative 1/2. Over here, I get 3x equals a negative 4 when I subtract 4 from both sides. Divide both sides by 3, I get x equals negative 4/3. So my solutions are x equals negative 4/3 and x equals negative 1/2. Example 3. The length of a rectangle is 3 times its width. The area is 108 centimeters squared. Find the length and width. So the first thing I'm going to do is just kind of draw a rectangle. I know that the area is equal to 108 centimeters squared. And then I have my width and my length. I know that area is equal to length times width. In here it tells me the length of a rectangle is, in math, is like an equal sign. So the length is 3 times its width. So we write that as 3w. So I'm no longer going to use this L. I'm going to refer to L as 3w. So now I have area equals length times width, and I can fill it in. area is 108, equals my length, which is 3W, times my width, which is W. That gives me 108 equals 3W squared. I'm trying to solve for W, so what I'm going to do is I'm going to divide both sides by 3. Okay, that gives me W squared is equal to 36. Then I can use what's called the square root property, okay, or the square root method. I can take the square root of both sides. I'm going to write that up here. Square root of 36. And I'm going to take the square root of W squared. The square root and the square undo each other, so I'm just left with W on this side. And just so you know, when you're taking the square root of both sides, you have to take into consideration the positive and the negative result. That leaves me with plus or minus the square root of 36. Well, I know that the square root of 36 is just 6. And I know that width is never going to be negative, so I can go ahead and ignore the negative in this particular problem. So that leaves me with a width of 6 and a length of 3 times that. So 3 times 6, which is 18. So my width is 6, my length is 8. For example 4, we have a similar question about a rectangle. The length of a rectangle is 4 centimeters greater than its width. The area is 77 centimeters squared. Find the length and the width again. So again, I'm going to start off with a rectangle. I have the area is equal to 77 centimeters squared again. I have the width over here and the length over here. Again, it's telling me something about the length. It's telling me the length is, remember, is equals. So the length equals 4 centimeters greater than the width. That is represented by W plus 4, 4 more than the width, or you could write it as 4 plus W. Now, remember, I know that length times width is going to give me my area. So my length is W plus 4, my width is W, and my area is 77. In this problem, one, we can't use the square root method that we did in the last one, and we can't really do anything until we have it in the right form. Remember that correct form is ax squared plus bx plus c is equal to 0. Notice we have 77 on the right-hand side. So what I need to do is first, I need to distribute this, okay? I need to distribute. That's going to give me W squared plus 4W equals 77. So what I did is I took this W and I gave it to the W and the 4. Then remember I need 0 on the right hand side, so I'm going to go ahead. W squared plus 4W, I'm going to subtract 77 from both sides so that I have 0 on the right hand side. Now I'm going to go through and I'm going to factor this. Remember, the first thing you always do is look for a greatest common factor, but there isn't one. So what I move to next is my AC method with the grid. So again, if you need to pause this, go ahead, but I'm going to write up the factors here. The factors come out to W minus 7 and W plus 11 equals 0. When I set each of these equal to 0, W minus 7 equals 0, that gives me W equals 7. Let me fix these equal signs. When I set W plus 11 equal to 0, that gives me W equals negative 11. Well, we already discussed that width cannot be negative, so I know that W is not equal to negative 11, so the width is actually equal to 7. The length is 4 more than that, so the length is equal to 7 plus 4, which is 11. There are times when you can't factor a quadratic, so we need to have an alternative method. That alternative method is using the quadratic formula. The quadratic formula, may make this a little bit faster. The quadratic formula is used once you have your equation in the form ax squared plus bx plus c equals 0. And the quadratic formula itself is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let me fix the way this is written. I don't want you guys to get confused. Plus or minus the square root of b squared minus 4ac. That entire expression divided by 2a. So again, once we have it in the correct form where we have equals 0 on the right-hand side, we can pull out what my a, my b, and my c are, plug those values in, and begin. For our first example, we're going to solve 6x squared plus 11x equals 10 by using the quadratic formula. So again, on the test, if it doesn't give you a method, you can always try factoring first and then default to quadratic formula if you can't factor it. Again, if it doesn't specify which way to solve it, then you are open to the different options. First, I need to get this in the correct form. I need it to equal 0, so I'm going to change it to 6x squared plus 11x. I'm going to subtract 10 from both sides, so that gives me minus 10 is equal to 0. Now, that means that my a, the coefficient in front of x squared, is 6, my b is 11, and my c is negative 10. Then I'm going to plug that into the quadratic formula. So remember, it's x is equal to the opposite of b, my b is 11, plus or minus the square root of my b term squared, so 11 squared, minus 4 times a times c, which is negative 10. All of that divided by 2 times a, which is 6. Okay, and then I highly suggest that you simplify in parts. So that's going to give me negative 11 plus or minus the square root of 11 squared is 121. We have minus and a negative, so that's going to give me a plus. 4 times 6 times 10 is 240, all divided by 12. So keep simplifying. X is equal to negative 11 plus or minus the square root of 240 plus 121 is 361. All of that divided by 12. Well, if you check the square root of 361 in your calculator, you're going to see that that is equal to 19. So x is equal to negative 11 plus or minus 19 divided by 12. So let me get my eraser, make a little bit of space, get rid of all this, make some room. All right, I need to simplify this even further. So notice that what this gives me is two solutions. It gives me negative 11 plus 19 divided by 12. And my other solution is negative 11 minus 19 divided by 12. And again, I have to simplify those. So negative 11 plus 19 is 8, so I have 8/12. And then negative 11 minus 19 is negative 30, so I have negative 30/12. And again, we want to reduce as far as we can, so that gives me the solutions 2/3 and negative 5/2. And so the 30 and the 12 were both divisible by 6, and the 8 and the 12 were both divisible by 4. So my two solutions to this are 2/3 and negative 5/2. Example 6. We're going to solve x plus 13 times the quantity x plus 5 is equal to negative 2 by using the quadratic formula. Well, first we have to get it into the right form, which remember is ax squared plus bx plus c is equal to 0. Obviously, it's not in that form. So on the left-hand side, what we want to do first is we want to go ahead and distribute or FOIL out the x plus 13 times the x plus 5. So I'm going to distribute. X times x gives me x squared. And then outside, x times 5 gives me a positive 5x. Inside, 13 times x is 13x. And last, 13 times 5 is 65. That's still equal to negative 2. Again, not the format we want, so I'm going to go ahead and add 2 to both sides so that I have 0 on the right-hand side. So that leaves me with x squared. I'm going to go ahead and combine like terms. 5x plus 13x is 18x. 65 plus 2 is 67. And that is equal to 0. Now I have it in the right form. ax squared plus bx plus c is equal to 0. Remember, I'm using the quadratic formula, so let me pick out my a, my b, and my c. My a is the coefficient in front of the x squared, which is 1. My b is 18. My c is 67. So I'm not going to have much room on here, so let me go to another screen and carry over that information. Again, I have my a, my b, and my c, so I move to the quadratic formula. The quadratic formula is x equals the opposite of b, so opposite of 18, plus or minus the square root of b squared, which is 18 squared, minus 4 times a, which is 1, times c, which is 67. All of that divided by 2 times a, or 2 times 1. So now if I keep simplifying, I get x equals negative 18 plus or minus the square root of, well, 18 squared is 324. Minus 4 times 1 times 67 is 268. And just do that in your calculator. Divided by 2. Continue to simplify. X is equal to negative 18 plus or minus the square root of 324 minus 268 is 56. All of that divided by 2. So now we have to look at the square root of 56, and we have to recall how to simplify these square roots. The square root of 56, if we take 56 and we break it down, remember that the square root of 56 is 2 times 28, my bad, and then 2 times 14. So we can take 56 and rewrite it as the square root of 4 times 14. The square root of 4 is 2, so that simplifies to the square root, 2 times the square root of 14. So x is equal to negative 18 plus or minus 2 root 14. All of that divided by 2. So we have to remember that this little area right here, if they're all divisible by the same thing, we can reduce it even more. So that's going to give me, they're all divisible by 2, so negative 9 plus or minus, that 2 turns into a 1, so the square root of 14, divided by, when I take this 2 and divide by 2, I get 1. So my two answers are negative 9 plus root 14 and negative 9 minus root 14. And that's how they're going to want you to type your answer into My Math Lab.